Section 6.2 homework 6.2.51-T. The question says, suppose that the probability that a passenger will miss a flight is 0.0996. Airlines do not like flights with empty seats, but it is also not desirable to have overbooked flights because passengers must be bumped from the flight. Now suppose that an airplane has a seating capacity of 55 passengers. In part A, it says if 57 tickets are sold, what is the probability that 56 or 57 passengers show up for the flight, resulting in an overbooked flight? So if there's 55 passengers, that's the maximum capacity. 56 and 57 is going to be over that 55. So let's take a look at this question here. Now, again, here's the first part, part A. By the addition rule for disjoint events, the probability that 56 or 57 passengers show up for the flight would be the probability of 56 or 57, which is the same thing as the probability where x is in between 56 and 57. Okay? Now, again, if you look here, it's telling us that if how many tickets are sold. Well, here it's telling us that if there's 57 tickets are sold, then for step 1, n is going to equal 57. Now, we want to determine the value of p, which is the complement of missing a flight. Well, the probability of missing a flight is 0.0996. So to find the probability, meaning the complement of missing a flight, we're going to take 1 and subtract 0.0996, which is equal to 0.9004. Therefore, x is going to equal to the number of people who show up between 56 and 57. So we want to find the probability that x is in between 56 and 57. So what we're going to do is we're going to go into StatCrunch. We're going to go to stats. We're going to go to calculators. But this question doesn't say anything about a Poisson distribution. So we're going to go to the binomial distribution. So with the binomial distribution, you see what we have for n. We're going to let that equal 57. And then we know the value of p, which is 0.9004, okay? And we want to find the probability where x is in between 56 and 57. So we're going to select between. We're going to put in 56, and then we're going to put in 57. And then you're going to see here is what we get for the probability rounded to 4 decimal places. It's going to be 0.0184. Thus, the probability that 56 or 57 passengers show up for the flight is 0.0184, which is about 1.84%. Now, looking at our result, you can see that we get 0.0184 for our answer. Okay? Now, the next question says, part B, suppose that 61 tickets are sold. What is the probability that a passenger will have to be bumped? Well, if there's 55 passengers and 61 tickets are sold, well, you can see that what's going to happen when a passenger will be bumped. Okay, so in this question here, it says a passenger will have to be bumped if more than 55 passengers show up for the flight. We're going to use the following equation to calculate the probability that a passenger will have to be bumped. Well, how many tickets are sold? That means that n is equal to 61. We also determined what p was because missing a flight is 1 minus 0.0996, which is equal to 0.9004. Now, if there are only 55 passengers allowed to show up for the flight, that's all the seats they have, well, bumped occurs when x is going to be greater than or equal to 56. So now what we're going to do is we're going to come back to this calculator. Now n is now going to change to 61 because that's how many tickets are sold. We know that the probability is 0.9004. And now we're going to go back to standard where the probability of x is going to have to be greater than 56. If we put in that probability, that tells us that 0.4246 is the value rounded to 4 decimal places. Therefore, the probability that a passenger will have to be bumped is 0.4246, which is about 42.46%. And therefore, there is our result. The probability that a passenger will have to be bumped is 0.4246. Now, the last question says, for a plane with seating capacity of 260 passengers, what is the largest number of tickets that can be sold to keep the probability of a passenger being bumped below 1%? This is more of a challenging question than the first two. Okay? So, for a plane with seating capacity of 260 passengers, to determine the large number of tickets that can be sold while keeping the probability of a passenger being bumped below 1%, we want to find the largest number of tickets such that the probability of X is greater than or equal to 261 is less than 1%. So in this case here, we don't know what N is. We're actually looking for N. We want to find out, what does N equal when we have 260 seats. Now recall that P, which is the complement of missing a flight, was 0.9004. Now being bumped occurs if X is going to be greater than or equal to 261. And so we don't know what the value of N is, but what we're going to try is, if we try 61, is that going to be below 1%? Is 262 going to be below 1%? So technically, we want to find out when N is equal to a value where it's going to be less than 1%, but then the next N value would be above the 1%. So let's take a look at the calculator here. All right, so I'm going to go ahead and say, okay, well, we don't know what N is, okay? But what we do want to know is that we need to find out the values of N where you're going to be bumped. So anything above 261. So what we're going to do is we're going to first put the number 261 in, okay? And so when we put the number 261, okay, we know that X is going to have to be greater than 261, right? So if we put in 261 up here, you can see here that this is 1.2813 times 10 to the negative 12, which is technically 0.0000. Okay, now let me show you this on our page here. Okay, so if we take a look at this amount, all right, and so we know the following. So this is the same thing as 1.2813 times 10 to the negative 12. And this is the actual number when you move that decimal to the place 12 times. And we want to make sure that it is below 1%. Well, if you look at this number, it is less than 0.01. Okay, so now we're going to move this up to now 262. Okay, now we get 3.459 times 10 to the negative 11. So below here, I just want to show you what I've done. When we put in 262 in for N, we get 3.459. If we move that decimal place over to the left 11 times, again, this number, 0.00000, is going to be less than that 1%. Okay, if we go to next to number 263, so again, all I'm doing is now going this to be 263, right? So if we said that N is equal to 263, now we're getting this number. Now moving this over to left 10 times gives us a number that's still less than 1%. Okay, if we put in the next number, which is 264, okay, again, just to see what happens here when we put 264, you can see that we get this probability, which again, if we move this over to the left 9 times, this number is still less than 1%. Okay, let's put in 265. So when N is 265, we get 0.0000003, which again is still less than 1%. Okay, let's put in 266. Okay, you can see what that happens with that number. It's now still, that number is still below 1%. Okay, put in 267. Okay, we can see that that number is still below 1%. Okay, let's put in 268. And you can see that that probability is still less than 1%. Okay, let's put in 269 just to verify this. If we put in 269, there's the probability for 269. 269. And you can see that that probability is still below 1%. If we put in 270, there's the probability, and you can see that that number is still less than 1%. Okay, next, if we put this value in there, again, you can see that this number is still below the 1%. If we put in 272, this number is still below 1%. If we put in 273, it's still below 1%. Put in 274, you see this value is still below 1%. 275, this number is still less than the 1%. 276, this number is still below 1%. If you take a look at 277, we get 0.009, which is still below 1%. And then when we get to 278, you can see that this 0.015 is going to be greater than the 1%. So it's anything below 277 is going to be below 1%. So therefore, our answer is going to be the following. Thus, the most tickets that can be sold while keeping the probability that a passenger will be bumped below 1% is 277. So if we go back to our question here, it says for a plane with seating capacity of 260 passengers, the largest number of tickets that can be sold while keeping the probability of a passenger being bumped below 1% is 277.